This is the discussion for what is chemistry, which is going to look at the scientific method and the different branches of chemistry. So we're going to first just talk about a definition. Chemistry is going to be the study of matter, its forms and its changes. Matter, we should know, or we will know, is anything that has mass, takes up space, has volume, and displays inertia. Forms, we're talking about all the different ways we can see matter. So, for example, that would be like solid ice cubes, liquid, gas, and then any kind of chemical change or physical change that's going to occur. We're going to study that in this class. Specifically, chemistry uses the scientific method, which would separate it from precursors such as alchemy, which is in a different discussion. We can break up chemistry into many different branches. Chemistry is a very large field, and then there's subfields. Here's just 5 to pose as an example of how chemistry can be broken up. Organic chem, looking mostly at carbon compounds. Inorganic chem, those that are non-organic. Physical chem, looking at how energy and matter are related to each other. Analytical chem, how things are composed, and also that might look at identifying substances. Then biochem, of course, that would be for more of a biology class type aspect. So we spend most of our time in inorganic chem, and then also in some analytical and some physical chem. So the scientific method, we said that chemistry is based upon it. It's a science class, and it's just simply a way of thinking in science. And we often use a teaching tool called FIAC to try to show how the scientific method works. But FIAC is exactly as I said, it's a teaching tool. That's not the scientific method. It's just a convenient way for us to teach scientific method to students. But it still has merit because it goes through the thought process that we're trying to develop. And what it's doing is it's showing that data can be directly correlated to a condition. We can say that this happened because of this. Condition A happened because of what we just did. And that's because of a controlled experiment. So the 5 steps of FIAC: problem, hypothesis, experiment, observations, and conclusions. A problem, wondering about something, anything, possibly at all. And questioning would be another way to say this. So let's pretend that we just got done eating at Buffalo Wild Wings and we had their hottest wings, and we're feeling pretty uncomfortable because of that. So the problem is we have had some hot wings and we have maybe some heartburn going on. What can we do about that? That's our problem. And you might know from past experience that you could take something like Tums, but you're thinking, wow, this heartburn's really bad. How can I make this heartburn feel better sooner? So perhaps you're thinking, maybe if I were to crush up the Tums really, really small as compared to just chewing them, that might affect how fast the Tums work. So then your hypothesis would be that the crushed into very small pieces Tums make the heartburn go away faster. That's your hypothesis. We can write that in an if-then statement. So if, then we have our hypothesis, crushed up Tums makes heartburn go away faster, then that's going to be your prediction. It would be something to the effect of the crushed up Tums experiment will make heartburn go away in a shorter amount of time. And then the experiment is going to be the test to see if the hypothesis works. So we would need to see if those crushed up Tums indeed work faster. But then we need to make sure that we are actually testing what we think we're testing. And that means we have to have a controlled experiment. So we would need to probably have an individual eat wings on one day and then eat crushed Tums and time how long it takes for the heartburn to go away. And then we need that same individual to eat wings on a different day and just eat the Tums normal, and then time how long it takes for the heartburn to go away. And we would probably want to do that several times because we want to make sure that our experiment's reproducible and that any individual results weren't just a fluke. And then we'd probably also want to have many people try that just to make sure that the results aren't for a single person. They're a set of results that would make sense across the population. So the experiment is a test designed For the hypothesis, we already talked about that. We're going to have some observations that come with that. Those observations can be either qualitative or quantitative. Qualitative would be qualities, so just descriptions. So that person might be able to narrate, oh, I'm starting to feel better. But then we could have quantitative descriptions, quantitative observations, actual timing. We could say, it was 14 minutes and 27 seconds for the heartburn to go away. So that's a number to add to an observation. Finally, based on your observations, what do those observations suggest about that hypothesis? Is it true or not? So if our hypothesis was that crushed up Tums make heartburn go away faster, we would expect to see a shorter amount of time. So if it took 14 minutes and 27 seconds for the chewed Tums or the crushed up Tums compared to 18 minutes for just the normal Tums, and we saw that consistently, that would suggest that our hypothesis is true. And we could say something along those lines. The data support the hypothesis, and that crushed up Tums do indeed make heartburn go away faster. Says here specifically, strong conclusions cite specific evidence. So we'd want to go ahead and say, in the crushed up Tum case, 14 minutes and 27 seconds compared to the 18 or more minutes for the normally consumed Tums. So we have this hypothesis, and that's about a specific situation. What if we see this hypothesis repeat over and over and over and over and over and over again among many different people across many different locations? Then we can start talking about scientific theories. And theories are sets of tested hypotheses that try to explain a larger part of nature. So probably not just for Buffalo Wild Wings, but we would say maybe for Buffalo Wild Wings and, Taco Bell and any other place that might have spicy food. Do Tums always work better if you crush them? Then we can start talking about scientific theory. So it's explaining how or why the phenomenon in science works. It's the mechanism. So it's trying to say this is why something occurs, which is very similar to a scientific model, which is more of a representation. So sometimes we could actually build something that would represent the idea. For example, you could build a model of a cell. You could build a model of an atom. You could build a model of the Earth's core to try to explain what we think is going on, to represent the science that we've already expected. Models can also come in a numerical format, such as an equation. So if you plug these numbers in, it's going to give you a predictable result. That would also be a scientific model. Finally, we have scientific laws, and they are also important for us because they are just the what's happening, more of an observation. It's a big observation of a phenomena in the world, but it's just saying this is what we see happening. Because it's what we see, it's very unlikely to be changed. Same with the scientific theory, probably not going to be changed, but because the theory is the why or the how, sometimes we get a little bit new information that'll tweak how we look at it. Sometimes scientific laws do go away, but it's very, very rare that they do because it's been repeated observations, repeated evidence that we see again and again and again. Therefore, it's probably not going to change. However, with science, with chemistry, with biology, with any science, if new data comes to suggest that a scientific theory or law or hypothesis is untrue, we're going to look at that data and then modify or completely reject a scientific theory or law if need be. But that's only after a lot of evidence, a lot of data has been collected that would suggest that the original thinking was wrong. So that would be the scientific method and how that connects to chemistry, and then the branches of chemistry and what is chemistry for the basic introduction to this class.